Thanks everybody for joining in to our webinar today on how to unlock smarter asset integrity with VisualAIM. I'll be doing the presentation today. My name is Alberto Diaz and I'm Operations Manager here at VisualAIM. And basically what we're going to share with you today are some of our lessons learned in the recent experiences we've had with multiple of our customers in the implementation of their asset integrity programs, in particular with how we have supported them using our intelligent drawing platform as a part of that process. If we look into today's agenda, as part of the context for today's webinar presentation, it's basically the fact that we very recently published a white paper in inspectioneering that was titled From Chaos to Clarity, a practical playbook for implementing mechanical integrity software. Some of you may have downloaded it and read it already, but it's basically a playbook that talks on how we have helped many customers implement their inspection data management systems and kind of taking them through the very stages of that process. What we're going to do in today's webinar is show you basically what we did in portray within that white paper. And it's essentially use cases utilizing our intelligent drawing platform tool to leverage some additional data collection capabilities from PNIDs directly and how that ties back to the different elements of that white paper that we published there. So if you're an MI program manager, you will be interested in this, as well as anybody from an operations or just a daily point of view of using PNIDs on a daily basis. The use cases that we will be covering are going to include gap analysis between PNIDs and existing systems of record, risk visualization, in particular for API 581 risk-based analysis and how to visualize that data within the context of PNIDs, CMMS alignment for computerized maintenance management system alignment of equipment taxonomies or hierarchies with the asset register of record, and a little bit beyond mechanical integrity into predictive analytics, kind of showcase there one of the use cases for a refinery that we helped out from that context. Then I'll kind of switch things over to do a very quick demo of the solution, particularly tailored to program sustainability with redlining, navigation, as well as definition of groups or circuits within the PNIDs. And then we'll conclude everything and kind of rehash what we discussed today. So within the webinar context, as mentioned before, we've already published the inspectioneering white paper on IDMS implementation and our lessons learned throughout that. I won't go into a ton of detail with it. And at the end of the presentation, if you haven't read it and you're interested in learning more, you can feel free to reach out to us out at VisualAIM and we'll be happy to send over the link. But basically what we're going to do is align the themes of the white paper content with the IDP use cases, which kind of worked in the background to support the implementation of the IDMS. And I have them in this particular order because I'll be tying them back to the specific sections within the white paper of how that use case enabled or elevated each of the table of content items from within the IDMS implementation itself. So with that said, I'll just go straight into the very first use case, which we've titled for gap analysis of a chemical plant. This is a use case that we've done multiple times in support of mechanical integrity implementations, either when starting from scratch when there's no program in place, or if there's already a program in place and an audit is to be conducted as far as if the asset register aligns with the drawing contents. So basically the objective of this particular use case was to extract the information that existed on the PNIDs, in particular all of the elements, instrumentation, piping, fixed equipment, to see if all of those tag names were present in the mechanical integrity system. So with our IDP tool, we're basically able to categorize or classify all of the existing symbology within the drawings and essentially capture that content and be able to generate asset registers. These asset registers with all fixed equipment, rotating equipment, lines, and IDs of everything that's stacked within the drawings. We then do a gap analysis against the system of record, which in the particular case of this use case that we're discussing was a mechanical integrity asset register. What we discovered from that particular analysis was that about 40% of the piping that was present within the PNIDs was not present within the mechanical integrity program. And that was a particular find that we were able to then complement with this particular customer, but just goes to show that sometimes what you're managing within the mechanical integrity system might not be 100% aligned with what's contained on your piping instrumentation diagram. So doing exercises like this helps basically close those gaps and make sure that you're covering all of the equipment that you need to inspect for compliance purposes within your facility. And if we tie that back to the themes within the use case, it basically goes first to scope requirements. So, again, regardless if you're starting from scratch in your mechanical integrity approach or you already have a robust program in place, if you're trying to figure out how many assets you're going to implement in your mechanical integrity program, the P&IDs is a very solid place to start as far as what the inventory should be in order for you to scope out what the implementation efforts are going to be from a mechanical integrity program perspective. In line with that, it also talks to the data quality of the actual documentation that we're looking against. Within the white paper, we go into a little bit more details on this, but depending on how legible, say, P&IDs are and the other sources of information, the amount of effort that it might take for you to do a mechanical integrity program implementation may vary significantly. In our approach, we prefer to work with CAD files for the data extraction, as we have seen that it yields the best results when we're generating the inventories from within the P&IDs. And tied with the first two, obviously the data collection requirements are heavily tied to the number of assets that you're going to be implementing. So having an accurate number that is derived from existing piping and instrumentation diagrams is often critical to glean this information and have conclusive numbers prior to the execution of the work. In this second use case, this is a very interesting project that we did with a refinery where kind of the problem statement or objective is that they had a lack of situational awareness because of the complexity of their RBI software. Essentially, they had solid results within the system, but it was at times difficult for them to properly contextualize what those risk levels meant from the context, let's say, of the P&IDs. So what we helped them do or enabled them to do was tie every single equipment that was present in the RBI program over to the intelligent drawings. That way, anytime that any particular inspector wanted to look for or understand the risk levels at any drawing, they could simply call the API, play the option, and it'll surface the level of risks as it currently exists within the RBI system within the P&ID, as you can see it on the screen. And of course, visually or from a contextual point of view, this gives the ability for any maintenance operator, inspection personnel, or even individuals from other disciplines like process to be able to really visualize and contextualize what the level of risk is for the different assets that may be present on any particular drawing. This is especially important when you're not necessarily familiar with the facility. You may be a new trainee or somebody who's new to the mechanical integrity approach on site. So being able to contextualize this kind of information can become extremely relevant and important. Within the context of this particular use case that we helped complete for this refinery, they basically felt that this brought their value forward many years in advance by being able to visualize and capture this information directly on the P&IDs. And the way that this ties back to the themes of the playbook is in two specific parts. One is the enterprise-wide implementation that also goes hand in hand with training and adoption. Basically, when you're going to implement a complex mechanical integrity program at a facility, especially if it involves RBI or risk-based inspection, the amount of data that you have to collect, analyze, cleanse, and run through the system can be quite daunting. And as a part of that process, it is extremely important that the individuals who are going to be involved in the evergreening or the updating of the program following the implementation are comfortable with the system. They have buy-in from the very beginning in order to enable that enterprise-wide sort of approach for the system. And having tools like this where they can visually observe and analyze how the information that they're inputting in the system is in a relevant way affecting the physical assets and visualize them on the P&ID can basically really allow for users and trainees to be much more engaged from the very beginning of the program and have buy-in from the very beginning, because visually contextualizing this information can be extremely powerful. From that point of view, and this is something that we really hone in a lot in that white paper, is the fact that we focus always on a lot of training across the various phases of the deployment. This is a phased approach matrix that we do present within the white paper, that kind of showcases how we typically go about these implementations, especially when they are across the enterprise. It's a lot simpler when you're doing a one-off facility implementation that you can kind of go start to finish in a very short amount of time. But when we're looking at multiple sites, 5, 10, 20, or 30 facilities that are being deployed in parallel, is better to approach everything from a phased point of view. In this first phase, we typically just go very high level. Let's import all of the assets as we see them on the registers, cross reference with the PNIDs. And at the end of this first phase, we focus on an initial training. This gives all of the users who are going to be part of the system the ability to start already looking at the program, be familiarized with it, even if it's not fully populated with all of the data that's really going to take it to the next level and make it capable of, predicting remaining lives and even running risk on the equipment. Same thing for phases 2 and phase 3. At the end of each and every one of these, we're basically complementing the database with additional information coming from other data sources, manufacturing files of the equipment, inspection histories. And at the end of these phases, we're always going back to the user base and providing the training with now the complemented information that exists within the system. Same thing happens at the third phase, when we're already connecting and linking to alternate systems, and also including the CML data as part of the program. Training is something that we make relevant at every phase of the project. And again, when you're able to include tools like the one that I just showed, where you can visualize the risk level as you execute the training so that the users can really see how their work and inputs is going to finally affect the program, is really valuable and solidifies that implementation from start to finish as you go through the particular program. The third use case, and probably one of the most intricate of them all, is what we call the CMMS alignment. We've done this a couple of times for different facilities at different stages, where if you're looking at it from a newly constructed facility, you would basically be building the computerized maintenance management system from scratch. And when we say CMMS, that's what we're referring to. But the most classic or typical CMMS systems out there, at least that we have seen with our customers, are going to include SAP, Maximo, and also Fixed by Rockwell, and a handful of others. But those first three are the really predominant CMMS systems that we see our clients use. And from that context, and leveraging existing PNIDs, what we're basically able to do is, by using the selector tool or the hierarchy tool within the solution, we're essentially able to structure taxonomies as derived from the PNIDs. And what we're showing here on the screen kind of portrays that to a certain degree, where the user can essentially select elements that exist within the PNID, and by that selection, they'll be added into the inventory, as you can see from the right-hand side of the view. And as you select those elements, they'll actually be highlighted in yellow so that the user can understand that those tagged items have already been included into the hierarchy. Visually, this provides a great deal of validity in the data that's being imported, because as you select each of the individual tags as they appear within the PNID, you are seeing how that essentially gets built out within the hierarchy structure. And beyond the understanding of what it is that you're selecting, anybody who comes into the drawing and then does a QC analysis on, hey, what is the coverage of everything that we have collected from this PNID into the hierarchical structure, it's extremely clear, because everything or anything that has a tag name that has been selected is clearly identified, as you can see from this color scheme. So it just helps in building out those hierarchies when you're looking at it from scratch. With that said, this particular use case that we're describing here was actually for a cross facility approach that we did for a particular methanol customer, where they wanted to align all of the hierarchies across all of their enterprise facilities with a singular framework of how they essentially structure parent and child relationships, going from plant, unit, and system all the way down to main equipment, related instrumentation, piping, and smaller components like specialty items and any other smaller tagged elements within the P&ID. Essentially, when you looked at the project from the beginning, each and every one of the facilities had a slightly different taxonomy structure to their CMMS hierarchies. And the problem that that was causing for the customer was that whenever they wanted to retrospectively analyze what the failures were at each of the facilities, it was very hard to derive or compare one facility to the next to try to see if they had common bad actors. Basically, if the configurations of this plant being similar, what was the recurring issue in plant A versus plant C that was causing the same problems? That was very difficult to do when there was no alignment across the different facility hierarchies. But by aligning them, they could basically do that analysis a little bit easier. The tricky part about this is precisely the problem itself. Given that every hierarchy or taxonomy was slightly different, and sometimes even the naming convention of the elements within the CMMS hierarchy might not have aligned 100% with the tags within the PNIDs, there was a lot of cross referencing to do to make sure that the asset registers from the CMMS programs would align with the elements within the PNIDs. Once we connected or linked those two together, then we essentially use the hierarchy tool that you're seeing on the screen to essentially reposition those elements under the appropriate parent items so that all of the taxonomies would line up from one facility to the next. With again, the biggest challenge being the volume of information that you're typically going to see, or the volume of functional locations that you're typically going to see in a CMMS program typically is going to exceed all of the tagged elements that exist on the PNIDs. So by focusing on the process elements primarily, all of your fixed equipment, rotating equipment, instrumentation, and essentially anything that's a tagged element within the PNID, we were able to restructure all of the components that were present on the PNID drawings to enable that alignment across the different facilities. As a result, we ended up basically scouring or analyzing over 500,000 different elements as they existed in both the PNID drawings as well as in the CMMS taxonomies, and aligned them so that the number of tiers or levels that you would have across all of the hierarchies was common for all of the sites. And again, what this resulted, or the end goal of this, was that now this particular customer, when they're looking back at their failure analysis or their reliability understandings of why certain areas or components are failing, they can compare from apples to apples from one side to another. What are the different areas, functional locations, or issues that they're having commonality with to basically address as best and as quickly as possible as they walk through this. And how is this all relevant to, or how do we tie this back to the IDMS implementation framework that we put together recently? That particular one is going to be integration to other systems. One thing that we cover extensively within the white paper is precisely the integration of mechanical integrity systems with CMMS programs. Once you have the mechanical integrity system in place, it's always desirable for that to talk to SRP or Maximo, such that whenever a nonconformance or an inspection recommendation is identified within the mechanical integrity software, you're able to, in a more automated fashion, create a notification or a work order inside of the CMMS precisely to address that particular nonconformance or that particular recommendation that has to be addressed. Same thing with the regulatory inspection schedule. After you've completed an inspection and you're basically scheduling out 5 or 10 years into the future, the next inspection that you're going to have to execute for that given tank or that given pressure vessel, you're basically needing or wanting to create a work order that's going to go along with that. And this is always a massive hurdle to connect these two systems, as we have seen it with our clients, precisely because the framework of how the two systems interact has to be very carefully delineated as far as, hey, do you want the request from the IDMS to directly create a work order or a notification in the CMMS system? And then what information that is being tracked in the CMMS do you want reflected back in the MI software? Is it going to be just a work order reference number, the status, the individuals who are involved in the approval process? All of those steps have to be clearly determined so that the enablement of the connection really works. And this ties back to the CMMS alignment framework precisely because of the problem that I mentioned at the beginning. There's a lot of misalignment between the functional locations based on our experience in the CMMS programs to what exists on the PNIDs and ultimately in the mechanical integrity software. Obviously, the key connection point between the IDMS reference and the CMMS reference is going to be the tag name of that asset or the functional location of that asset. And whenever there is a mismatch in that naming convention from the IDMS over to the CMMS, you are, of course, going to have a conflict there because you wouldn't know to which element within the hierarchy taxonomy structure you're trying to create the work order against. That's why this step of structuring properly the CMMS taxonomies is critical, such that then when you are going to tie the two systems together, there's actually some alignment to be done with. And part of that is not only that the levels are appropriate, but that the elements themselves exist within the CMMS. Because again, a lot of times what we have seen is that you will have a lot of main equipment or elements within the PNIDs that do not show up within the CMMS system. And by performing projects like this, where we can compare the tagged elements on the PNIDs and therefore the MI program within the tagged elements of the functional location structure of the CMMS systems, we're able to ensure that when the connection is going to take place, there is a counterpart of the element from the IDMS over into the CMMS. The fourth and final use case that we'll be discussing today is this one regarding predictive analytics. This one ties a little bit more to kind of the ending section of the white paper, in particular when we go a little bit beyond mechanical integrity. And we bring this in because, as I've mentioned before, IDP, or the Intelligent Drawing Platform, is a tool that leverages existing PNIDs, in particular for mechanical integrity implementations. But after the clients have this tool in place, a lot of other ideas come into the mix as far as, hey, what else can we do with the solution after we have implemented it? And this is precisely one of those situations where the customer was able to leverage the existing IDP platform, in this particular case, to align the elements of the drawings or the instrumentation with the data historian channels or data stream to configure their predictive analytics project. Essentially, they needed to create data packages so that they could state for any given piece of equipment, either a tower, a pressure vessel, or even a pump, the given variables that they would desire. A simple example that we have in here for a pump would be maybe the discharge pressure or the flow rate, and align the actual instrument labels as they exist on the PNIDs against those required variables. By aligning the instrument labels with the variables required for the predictive analytics system, that was then cross-referenced against the data historian data channels, so that in the data package to the predictive analytics system, the every single in-scope asset could have their required data channels in order to create the predictive analytics systems and be able to run the models. So essentially what IDP helped in doing was creating the data pack that ultimately ended up within the predictive analytics system. And we did this in a very similar way to how we did the prior project of the CMMS, using our hierarchy tool, as it is very flexible to do many things that require selecting or structuring information that exists within the drawings into a hierarchical or taxonomy structure as you build it out. So this simple example right here kind of portrays that, in which the asset in the center of the screen, in this case the vessel 2D783, has a number of different variables of interest, one of them being the particular level that's being measured at the asset. And then what the tool allows you to do is select the particular set of instruments that you're going to associate with the given variable, in this case, the level of the vessel. And by selecting on the appropriate loop that's measuring the level of the equipment and that it is directly attached to the asset, the user is then able to select that loop into that level of the taxonomy to state that in this case, level instrumentation loop is attached to the asset as it's measuring the level of 2D73. And that was the information or the mechanism that we used to align the instrumentation tags with the variables of the equipment and then simply cross reference that against the data historian, in this case, OSIPy, to provide the pertinent data channels that align with each instrument label into the data package and enable the predictive analytics system. What was in turn the value that we provided to this particular customer? The scope of work for this project involved over 5,000 PNIDs, piping and instrumentation diagrams, and we were able to then execute this work thanks to the hierarchy tool within IDP in 12 weeks, as opposed to the originally expected 2.5 years that this might have taken the customer just by manually reviewing the drawings and collecting this data into Excel. Not to speak of the potential data entry issues that they might have had as part of this particular process. So by leveraging the tool, we were able to complete this in a very short time span and essentially permit or allow the customer to realize the value of their predictive analytics program at least 2 years in advance of their original expectation, saving a lot of money and bringing the value of the program forward by those 2 years that they were not actively monitoring the equipment. And again, tying it back to the themes of the white paper, this is one of the items that goes basically beyond mechanical integrity. Once you have VisualAIM tools in place or within your ecosystem, and many disciplines are utilizing the tools, in particular the intelligent drawing platform tool, more ideas seem to come out similar to this one, where, hey, how else can we use or leverage our existing drawings in order to enable other systems, other tools, or get the information that we need? And this is precisely one of those use cases where, going beyond mechanical integrity, you can leverage existing PNID drawings to enable other projects or other applications, like in this case, predictive analytics. And just to name an additional one that kind of goes in this same theme, this is something that we are starting to implement quite successfully with many of our customers, that precisely ties the intelligent drawings with other systems within their facilities. As you can see from the screenshot here, within the view, in the context of going a little bit beyond mechanical integrity, it's showing you the context of the PNIDs with mechanical integrity data coming from the IDMS. But beyond that, it's also incorporating 3D photogrammetric visualizations of the facility, as well as map views of where the particular asset is located within the site. And we provide this to show what else you can do with the tool after you have them all in place. And you can see that this starts to basically delve into other areas that are not only mechanical integrity. People from operations, from process, electrical, or even external contractors or new trainees can use these types of tools to guide themselves better in the facility, essentially allowing them to locate equipment a lot faster, especially if they're not familiar with the site. If the facility is particularly remote, this helps even more in understanding where the equipment is located and being able to plan ahead of time the work that's going to be done. One example that we always give for this is scaffold measurement. Say that this facility is located in a remote area and you're needing a contractor to go and do a particular task at this site. It would be very ineffective or cost ineffective to have them go on site prior to doing the work so that they can measure and scout the area to understand how it is that they're going to approach the work, increasing the cost and the time for the execution of the work. When you're able to access these plant views along with technical documents like PNIDs within the tool, you're able to do all of this work planning remotely and ahead of time, saving a lot of costs as part of this process. Because the tool does allow you to do for example, measurements to understand how much scaffolding you're going to need in a particular area to either, repair an asset or address any particular integrity issue that you might have on site. So this is one of those examples of taking it beyond mechanical integrity as far as what else can be done with the tool. A lot of process teams, when they're doing also their hazard analysis, can leverage this type of visualization when they're conducting those risk studies to better understand where they can mitigate the risks related to the HACCPs as they're doing their given analysis. So that's how it ties back to the playbook and how the tools that we have in place can be leveraged for even more value added into the particular facility or operation. With that said, I'm now very quickly going to switch over to a fast and sort of high level demo of the IDP platform, because everything that I've shown to date are just samples so that you could get a feeling of the different use cases. But now I'll quickly switch over into the actual solution to show you three key elements of it. The first is going to be navigation, as far as how the tool can be leveraged to quickly locate assets when you may not be familiar with the facility or with the drawings. It'll also portray redlining, which is particularly important for the sustainability of the program. And that goes hand in hand with the groups as well. Groups for us are the definitions of any highlights on the PNIDs. From the context of mechanical integrity, this is typically, or from a class point of view, going to be systems and circuits, but it could also be HAZUP nodes from the process group or even LDAR groups for the leak detection system. So I'm just going to, at a high level, show these capabilities just to portray how these items can support the ongoing and sustained mechanical integrity programs at your facility. This is the IDP tool as you would see it on the screen. And as soon as you log in, you're going to see a list or an inventory of all of the available drawings that you have at hand. And basically from here, you can search for any drawing, access the information, or click on any of the ones that you want to directly access. Throughout the presentation, you've heard me say PNIDs for the most part because it's 90% of what we do or how we approach the projects from a PNID perspective, being one of the most important documents. But any two-dimensional CAD file we can process, including, as the example here on the screen, isometric drawings as well. So starting with the theme of navigation, this is the place where I like to start with to showcase or leverage how you can quickly access or find equipment data across the PNID set. Let's say that I'm a new engineer, I'm not familiar with the site, and I quickly need to get to a particular asset. In this case, let's go for vessel 1001. I might not know where this equipment is located, so I can quickly do a search on the platform. And what this is going to enable for me, it's going to tell me every single place across the entire database where that tag name that I've just searched for is located. And you can see that it can either be a unique reference or it could be contained within a string of text, like in this example of this level valve that does include that label, but isn't necessarily the equipment that I'm looking for, and some additional references that, again, aren't exactly what I'm after. But it lets you know what the text is, if it's either a block or a text, the type of drawing where it's located, and then the particular drawing reference or name that it is. So what this enables me to do, by clicking on that element, I can quickly jump on that particular drawing and kind of see if this is what I'm looking for. And I purposely clicked on the isometric just to showcase the fact that those are also available, or you can enable the connection to them. And one of the key things that a lot of our customers like to do is actually tying the CML points back to the IDMS data so that you can click on a CML, view the corrosion history, view the different thickness dates, and essentially trend out what the corrosion is at any particular CML. But going back to the example that we were looking at, when I'm trying to get to my equipment or my vessel VO1001, the reason for which I got this result is because that text does exist in this PNID, but in this case, I'm looking at it from the context of the isometric. And let's say that, for instance, I'm actually interested in the PNID view of this particular vessel. I can quickly navigate back to my search results and essentially go to the next drawing where I suspect that the asset might be located, because again, this is looking at all of the text content across the database and letting the user know where that V1001 appears across the drawings. And you can see from this particular PNID that I'm actually getting a hit here at the bottom left-hand corner of the PNID. So I see the reference that I'm looking for, V1001, but it's not really the asset that I'm after, basically. It is, however, an off-page connector reference that tells me that most likely the equipment that I'm looking for is on that associated PNID. So what I can essentially do is click on that off-page connector, and I can see that I have a navigation link to the associated drawing. So I can quickly click on that particular element, and it'll now take me to the associated drawing through that off-page connector link, and I can now see that this is in fact the vessel that I was looking for. So I portrayed all of those examples just to show the fact that the IDP tool can let you quickly investigate where the tag name that you're looking for is located. And even if it's not the main drawing that you're after, it gives you good hints and clues as far as where you need to go next to really get to the information. So it's very powerful from that navigation perspective. Once you're within the drawing itself, there's a couple of key things that you can do here as well. In particular, depending on who the analyst or the person looking at the drawing is, you might be interested in changing the color scheme of the drawing. What this allows you to do is see the coloring scheme that was used in the native AutoCAD file. And that way, depending on who drafted the drawing, you might be able to distinguish, say, process lines from tubing or main assets from instrumentation, depending on the color scheme that was utilized. So this does allow the users to visualize this context without having to have AutoCAD basically installed in their computers. From what I showcased earlier in the use cases, I can also get to my equipment inventories. And if I want to understand, hey, what are all of my discrete instruments from this particular PNID, I can essentially understand or analyze that. In line with the theme of the program sustainability, as mentioned before, in particular, tracking of red lines, that is another key feature that IDP has. And in this example, I've got a ton of red lines that I've done, in different demonstrations where you can basically surface what the red line was in the past. This is particularly useful for the sustainability of the programs because, as I'm sure that many of the folks that are on the call have experienced, is extremely common for red lines and paper copies to essentially get lost. You might have a project that involved some management of change that required the configuration change on a given area of the facility. The work was done. The red lines were in fact, traced or taken into account manually or on PDFs. And at the end of the chain, it might get lost as part of that process in some stick file somewhere with a stack of other PNIDs that were never introduced into the management of change process for the actual master CAD files. What this allows you to do is to electronically catalog these red lines, understand who was the person who did the red line itself, the date in which it was executed, and essentially introduce it as part of the MOC process and send a notification to, say, the drafter or the document control person in charge to offset or start out the management of change process to execute the change on the master CAD file. So this is an extremely powerful component of the IDP tool in order to sustain the program moving forward. The third and final element that I mentioned in the PowerPoint before switching over to IDP is precisely the visualization of groups within the PNID drawings. Groups from the context of IDP can be any highlighted layer on the PNID. And in this case, what we've done here for the showcase, and let me zoom in a little bit more so that you can see this a little bit better, it's that we can actually categorize the different groupings that we're visualizing on the drawings. From the specific context of mechanical integrity, a key, highlighted reference on a PNID is always going to be your piping circuits for inspection. And that's precisely what we're showing here on the screen. And if I visualize or surface all of these within the drawing, you can see how the drawing highlights accordingly to portray each and every one of those drawing layers within the PNID. The key advantage of this from the context of IDP, aside from the obvious visualization, is the upkeep and sustainability of this across time. We've seen, or our experience with the mechanical integrity departments that we've worked with, is that they'll typically get a PDF issue from the document control team. They'll highlight their circuits on those physical PNIDs. And 6 months or 1 year into the future, those PNIDs are now out of date, and they have to essentially do the process again on newer versions of the drawings. When you leverage the IDP tool, you can reprocess later versions of the PNIDs and not lose any of the circuit definitions from the original set of lines that you had. Any new lines introduced or taken away would obviously require certain adaptations, but all of the lines that remained exactly the same, connections that didn't change, you would keep those exact same circuit definitions upon the PNID. And then if you wanted to, you can actually export them as layers on the CAD file if need be within the system. The other key part about the group settings within IDP is you can actually have different categories of the groups that you're visualizing. In this case, I first showed the piping circuits, but I can switch over, say, to my piping systems and be able to visualize within the same drawing without having to change, pretty much anything, a different set of highlighted groups within the PNIDs. This can be extremely powerful, as mentioned before, because multiple teams get leveraged at the same time. You're not having to have the mechanical integrity department with their circuits, and separate to that, say, the process team with their heads up nodes. It can all be centralized within the same system and kept up with the latest versions of the masters as newer versions come into play. So, once again, from a sustainability perspective of your MI and overall program within the facility, IDP can really, really be leveraged in order to support your different processes across time. In conclusion, and to kind of wrap up everything that we've presented today, we've basically gone through and tied a number of different use cases that we've typically used IDP with, from direct client requests in support of the inspection data management system implementations that we've done in the past. Basically, what we're trying to showcase there is, even though our focus a lot of times is on the IDMS implementation, there's a lot of support that comes in from the IDP tool that it's then leveraged for even more value creation by our customers as they become more and more familiarized with the system. Everything that I showed you again came directly from a client request and a project that we ended up executing as tied to those particular client requirements. And obviously, tied to that, a PNID is an ever evolving document, which is clearly a key part of the program sustainability and has to be kept up to date for the longevity of the program within and across facilities. So I'm just rehashing the fact that that is extremely important, and IDP does allow you to progress on that sustainability path by redlining your drawings and allowing you to reflect groups across different changes of the master CAD files. And as a conclusion of that, of course, PNIDs are very much a key multidisciplinary document in any chemical process plant that really supports many different groups and activities on a daily basis. And all we're trying to do with our customers is essentially support them in their different approaches, needs, and requirements as they progress with their mechanical integrity programs and alternate digital enablement capabilities. So, in today's webinar, we simply wanted to go over all of those points and kind of showcase for you some of the key use cases that we have utilized in the recent past in order to support our clients as a part of this. So, I'm also including my email and the VisualAIM website to encourage anybody who has either further questions or would like a more in-depth demo of everything that I've shown today. The team and I would be more than happy to showcase that for you. And if you missed our white paper that we published in Inspectioneering that I mentioned at the beginning of the call, and you'd like to have that link, feel free to reach out to myself or the contact page at visualaim.com, and we would be more than happy to resend that link out to you so that you can have access to that information. So we're up a few minutes early, so I'll give everybody 15 minutes of their day back. Thank you all very much for your attention today, and I hope to be speaking to some of you folks soon. Thanks a lot.